Hey everyone, if you're building software, then you're also the person building its walls and defenses. The question is, where do you even start? Well, today we're going to break down the three big ones: how you handle input, how you authenticate users, and how you authorize what they can do. Let's dive in. All right, let's kick things off with a pop quiz. What do you think is the number one source of attacks on an application? I mean, when things go wrong, where does the trouble almost always start? Think about it. Every single form, every search bar, every little place a user can type something in. What do they all have in common? Yep, it's user input. That's the one. It is literally the front door to your entire system. And if you think about it, that means every single piece of data a user sends your way is a potential threat. That's why we have to start our security journey right here, at what I like to call gate number one. So this first gate, it's everything. It's your absolute first line of defense because it's the only way anything from the outside world gets in. And let's be real, if this gate is flimsy, it almost doesn't matter how strong the rest of your security is. We're talking, of course, about handling user input securely. The main idea here has a name: input validation. And it all comes down to one single golden rule you have to live by. Never, ever, ever trust user input by default. You just can't. You have to work from the assumption that every piece of data coming in is actively trying to break your system until you've proven it's safe. It's not being paranoid, I promise. It's just smart security. Okay, so how do we actually do this validation? It's basically a little checklist. First up, type. Pretty simple, right? If you're asking for someone's age, you're expecting a number, not their life story. Then there's length. If a username field gets a submission that's 1,000,000 characters long, yeah, that's probably not a real username. That's an attack. You also check the format. Does that email address someone typed in actually have an @ symbol and a dot something? And the big one, sanitization. This is huge. It's where you actively clean up the input, stripping out or neutralizing nasty bits of code that an attacker is trying to sneak past you. Because if you mess this part up, someone could literally type a database command into a search bar and potentially dump your entire user table. Yikes. All right, so let's say the data made it through gate number one. It's been checked, it looks clean, we're good, right? Not yet. Now we get to gate number two. The data might be safe, but we still have no idea who sent it. This next gate asks a very straightforward question. And that question is, who are you? This is where authentication comes in. It's all about verifying identity. You know, when a user types in their username and password, they're essentially raising their hand and saying, hey, I'm Bob. Authentication is your application turning back and saying, oh yeah, prove it. And luckily, we have a lot of great ways to do this now. We're way past just a simple password, right? And speaking of passwords, they should always be hashed, never ever stored as plain text. But that's just table stakes today. We add extra layers like multi-factor authentication, MFA, you know, the little code you get on your phone. We use secure tokens like JWTs so you don't have to log in every 5 seconds. And in the background, things like solid session management and rate-limiting login attempts are your silent bodyguards against brute force attacks. Okay, so the input is clean. We know who the user is. They've passed the first two gates, so they can just wander around the castle and do whatever they want, right? No way, absolutely not. Now we get to the third and maybe most overlooked gate. This one is all about permissions, and this is called authorization. It's so important to get this. Authorization always comes after authentication. Just because I know who you are doesn't mean I know what you're allowed to do. They're totally different things. Authorization is the bouncer checking your ID for every single room you try to enter. Every single time. Let's stick with that building analogy. Authentication is the key card that gets you through the front door of the office building. Great, you're in. But authorization, that's what determines if your key card can also open the server room door, or the CEO's office, or maybe just the door to the coffee machine. One gets you in the building, the other decides what you can do once you're inside. This all leads to what is basically one of the unbreakable laws of good security, the principle of least privilege. It sounds fancy, but it's simple. You give users the absolute bare minimum permissions they need to do their job and nothing more. Think about it from a sysadmin's point of view. You create roles, you've got an editor, a viewer, maybe a commenter. A viewer can see things, but they can't change them. An editor can change their own stuff, but they can't delete the whole site. Why? Because if an attacker gets control of a viewer account, the damage they can do is super limited. It's all about shrinking your potential blast radius. Okay, theory is great, but what does it look like when one of these gates actually fails? Let's walk through a super common and frankly pretty scary scenario to see how this all plays out in the real world. So here's the scene. We've got a user, let's call her Alice. She goes to your website and logs in with her username and password. Everything checks out. The system confirms who she is. Boom. Gate number 2, authentication, is a success. Alice is officially in the building. So Alice is browsing her own profile page. She happens to glance up at the URL in her browser and sees something like https www.google.com search.q, mysite.com, profile %3 fid%3d123. That's her user ID 123. Then she gets an idea. What if she just changes that number? She deletes 123 and types in 124, the ID for another user, Bob. She holds her breath and hits enter, and bam. Up on the screen comes all of Bob's private profile information. So what just happened? This is the failure. The system saw that Alice was authenticated. It said, yep, she's a real user, she's logged in, but it completely forgot to do the next check. It never asked, okay, but is she authorized to see profile number 124? Because that simple check was missing, it just handed over the data. This is a textbook example of broken access control, one of the most common vulnerabilities out there. It happened because gate number 3 was just left unlocked and wide open. So how do we make sure that never happens in our code? Let's tie this all together into a really simple blueprint, a mental model you can use on any project. Think of this as the secure path that every single request needs to follow. No excuses. It's a simple 3-step flow. First, all incoming data, and I mean all of it, has to pass through gate number 1. It has to be validated and sanitized. No exceptions. Second, if a user wants to do anything that isn't public, they have to pass through gate number 2, authentication. We have to know who they are. And third, this is the one people forget, once we know who they are, every single request they make has to pass through gate number 3, authorization. We have to check. Does this user have permission to do this specific thing? Not just once at login, but every single time. So here's your takeaway. Your developer security checklist. Print it out, stick it on your monitor. 1. Never trust user input. Assume it's hostile. 2. Always validate that input. Check its type, its length, its format. 3. Use strong modern ways to authenticate your users. And 4, the big one, check authorization on every single request. And underlying all of this, that principle of least privilege. Don't give anyone more power than they absolutely need. And that really brings us to the final question, the one I want you to take back to your own work. Take an honest look at your code. Which of these 3 gates is your weakest? Are you a little too trusting of user input? Is your authentication a bit outdated? Or are you maybe, just maybe, forgetting to check authorization on every single request, just like in our little story? Finding your weakest gate, that's the first step to making your application truly secure.